Hey guys, do you find yourself writing a long if-else statements whenever there is a new feature is added or try to keep increasing the conditions? Well, that is a problem. So we are going to solve this problem with a strategic pattern. The strategic pattern. We are taking a real-time use case and we are solving with a strategic principle. So our code will become more flexible and maintainable. So let's dive in. Imagine you are building an e-commerce platform where users to pay using a different payment types like could be a credit card, a wallet, or a cash, or could be any UPI or crypto. So our general expectations when we are building a such system, our application should be extendable to multiple payment options. So this makes the system scalable and ready to feature enhancement. And also it should be a well maintainable, so we can extend the logic without changing any core logic. So it should be a extendable and well maintainable. And also our expectation, it should be a runtime flexibility also, like a user should be dynamically select a payment method at a runtime without restarting the system. This makes application more flexible. So now let's see how we can solve the same problem in a common approach, and we can how we can resolve the same problem with a strategy pattern. The easiest and most common approach is to use a payment processor class with an if else or a couple of switch statements to handle different payment methods. So we are identifying and executing the respective payment logic by sending a payment type as an input object. But what if we need to extend this payment processor logic for a couple of other payment types? Adding additional if-else statements to include further payment types like UPI, crypto. So this approach is violating a couple of principles and it has a couple of drawbacks. Let's see. It's violation of open close principle. Adding a new payment method requires modifying the core logic like a process payment method. So including every time a new condition. And it has a poor scalability. As a new payment methods increases, every time we need to include additional if else conditions, so the conditions will grow and it is hard to maintain. The if logic for each payment method changes, we have to modify the main class every time. Now, if we talk about the strategy pattern is a behavioral design pattern that allows selecting an algorithm at runtime by defining a couple of family of algorithms and making them interchangeable. So it promotes a couple of principles, like promotes open close principle, and it gives the maintainability and scalability of the code, and it encourages the code readability and separation of concerns, and it supports dependency injection as well. Now we are trying to apply a strategic pattern in our use case. Firstly, identify a common action between the strategies and put them into an interface. So instead of putting all the logic in one class, we created a separate classes for each payment method and we added a concrete implementation. Now define the payment context, which allows to set the strategy at the runtime and do the actual process of payment. We call this from the client code by creating an object to the specific strategy, and we set the strategy and we execute the strategy. Now we can extend these strategies to multiple different types of strategies. Let's say if you want to implement again additionally a UPI payment strategy, we can extend this with the iPayment strategy. So this is resolving a couple of issues like using multiple if else statements, and also it is giving further more um, benefits like maintainability and scalability, and it's following the open closed principle by creating separate concrete classes for each payment type. And also it has the runtime flexibility, like if we can dynamically switch payment methods at runtime. For example, if user selects a PayPal or UPI, we can give the option to the user. He can select a specific strategy and we can execute the specific strategy by setting to the context. And also it has few drawbacks here as well. So when it comes to drawbacks, it directly depending on the concrete classes, and the client application needs to know all the strategies which are available, and we're manually creating the object for the concrete classes. So we are going to resolve all these issues with the help of dependency injection. Let's try. So dependency injection is a design pattern that helps to manage object creation and its dependencies. So instead of creating objects manually, the framework injects the required dependencies automatically, making the code more maintainable and testable. So it promotes loose coupling and improves the scalability, and also it's a better separation of concerns in application. So here I'm using a .NET 8 application as an example and registering all the payment strategies like credit card, PayPal and UPI. And also I'm registering the payment context. Here I have used add transient so that the new instance is created every time whenever it is requested. Now we are creating a payment strategy resolver. Instead of relying on multiple if-else conditions, this resolver will help us to choose the right strategy dynamically. Now we created a dictionary which will hold the list of payment method names and with their respective classes. Now whenever we need a right payment method strategy, we call this get strategy method. This will return the correct strategy instance dynamically. Now we're registering this payment strategy resolver as a singleton. So this ensures that there is only one instance for the payment strategy resolver for the entire application. Since strategies doesn't change frequently, the single instance is enough, and it will help us to improve the performance by avoiding unnecessary object creation. So this way, all parts of our application can access the same resolver instance without needing to recreate the strategy resolver object every time. Now we're integrating everything into a controller so that our payment processing system is available as a REST API. So this controller will receive payment request via HTTP post call, and it uses the payment strategy resolver to dynamically select the correct strategy. So the payment context to process the payment using a selected strategy. So this approach makes our payment system completely dynamic, and we can add a new payment method without modifying any of this code in the controller. Now let's run the application and try to execute the payment with the different amounts. So now I'm trying with the UPI payment, and based on the name of the payment, the selection of the strategy got happened internally. Now we could see that 3000 got paid with the UPI payment. Now if we try with the different payment method with a different payment amount, so now if I execute, the process got successful, and if we check the console, we could see that it's a 5000 got paid with a credit card. So the strategy got selected dynamically based on the name of the strategy name. If we recap what are the things we have achieved with the strategy pattern, we have cleared all the if-else statements, and we have done easily manageable code, and also we have followed open close principle, and we have done a runtime flexibility code. Apart from the above points, we have cleared the drawbacks whatever we have seen in the previous example. We have avoided direct dependencies on the concrete classes, and the client application need not to know the all available strategies and not required to create object manually from the client application. I hope you found this video useful. If you did, give a thumbs up and subscribe for more design pattern videos, and let me know in the comment section which pattern you would like me to cover in the next video. Thanks for watching.